Golden Gate Bridge. When I went last time, I biked across it and it was extremely windy. Fun fact. I know, nobody asked, but it was still fun. Would recommend. And my grandma actually went on the Golden Gate Bridge on the day that it opened. She talks about that every time I see it. So, what do we have here? We're given a model for the height of the suspension cables, right? So it's a suspension bridge above the mean water level. And that can be modeled by this function h equals k of x minus 640 all to the power of 2 plus 67. All right. And we're given some more information about the midpoint is 67 meters above the water level. So height of 67. And the distance between the towers is 1280, right? So we could do like the halfway point would be 640. And we know that this cable is 67 meters from the ground. So this has a point of 640, 67, right? That's the midpoint, which we can actually just read from this function here, right? That's in vertex form, and the vertex is that midpoint there, that turning point. An anemometer, guys watch Finding Nemo, anemometer, shown as A, right? So it just detects wind speed, because they might need to close the bridge if the wind is gusting too strong. So it's positioned at point A, and it's 100 meters above the water level, so that's labeled. So it has an H value of 100. And we're asked to find this horizontal distance, in other words, this X value here. So, starting with the function we're given, I notice K, right, that scaling factor K, it determines how wide or how narrow. So it could be like this, or it could be like that, depending on the value for K. We aren't given that, so we should work that out. So to work out the value for K, we need to substitute in a point. If you're thinking, let's put in this midpoint, give it a go, see what happens. I will pick another point. Let's pick at x equals 0, h equals 227. Right, so that's just the height of one of the pillars. So the point is x equals 0, height is 227. And we're putting it in the function for h, which is k x minus 640 squared plus 67. Yep. So substituting in that point, and for x and for h is 227, k, that's what we're looking for, x is 0, minus 640, squared plus 67. And if you solve for k, we get, what do we get? 227 minus 67 divided by minus 640 squared equals k, which, putting it in on our calculator, 227 minus 67, 160, divided by 640 squared. And I can just do 640 squared instead of negative 640 because the negative will be timesing by a negative, so it'll become positive. Anyway, so we get this thing. You might not have seen this notation before. So that reads 3.90625 times 10 to the power of negative 4. So it's scientific notation, but with an e instead of times 10 to the power of, right? It's calculator notation. So 3.90625 times 10 to the power of negative 4. Right, you could leave it like that, that's fine, or you could write it as a decimal. So if it's been a while for you, Show you how I teach my year 10s. Come on. So -4, we shift the decimal point 4 places to the left. So let's just put a bunch of leading zeros. 1, 2, 3, 4. So this as a decimal would be 0.3 zeros, 1, 2, 3, and then our number. Right, so that's the decimal equivalent. But leaving it in scientific notation is fine. However, do not leave it in calculator notation. So don't use an E. Make sure you use times 10 to the power of. Oh, come on. All right, so we found K. Now my computer's bugged. Oh, we're back. We found K. Now we can plug that back into our model, right? Our function for height. So K is 0.000390625. The rest of the model is the same. Great. And now the question is find the horizontal distance, right, which is x, given it is 100 meters height, like 100 meters above the mean water level. So that means we substitute in 100 for height, and we solve for x. So a few ways to do this one. I'll show you it graphically first because that's the fastest. So menu 5 for graph. Let's delete all those other bits. Delete. So we put in a function which is 0.000390625 bracket x minus 640 bracket squared plus 67. So that's our model, and we'll put in the function y equals 100, right? So that's a horizontal line at y equals 100. And for them to equal each other, so let's hit draw. Your window might be out of whack like mine. So let's make the minimum 0, right? The x min, it starts at 0. Let's just look at the problem, eh? And then x max is about 1300. That's like the full width. And then the height goes from obviously 0 up to about 230. So now if we draw, we have our bridge, the parabola, and that horizontal line is actually this line right here, which intersects point A. And if we hit F5, gsolve, we hit ISCT for intersection, we can see that when y is 100, x is 349.3. You could also hit the right arrow and see the other intersection point, but we're only interested in point A. So by graph, on graphics display calculator, x equals 349.3 meters. And that's a perfectly valid approach. The more algebraic way is to expand out this equation, take everything to one side to get a quadratic, and then solve. So I'll leave that up to you to try. Try use the quadratic formula or completing the square, or using polysolve on your calculator. So to summarize this question, we first had to complete a model, so we were only given part of a model. We had to use a point, either this one or this one, not the turning point, as that wouldn't have given us any new information. We solved for k. Then we use that model to find a horizontal distance x by substituting in 100 or by graphing it.